Good to be back. Some of you may remember me from last year. I'm Bart, the creator of Hologram, and I talked about the ideal developer experience and the ideal architecture of a web framework. Last year was about what Hologram is and why it exists. This year is about what happened since and where it's going. And where we're going is local first. But first, two things I want to show you. That's a game running in your browser, written entirely in Elixir. That's the code, pattern matching, pipes, pure Elixir. There's no JavaScript written here, 0. Hologram compiled it for the browser. Second, this. Each keystroke updating state, no hooks, no JavaScript glue, no round trip, purely client-side. A year ago, neither of these demos would have been possible, so let me show you how we got here. Last summer, I shipped version 0.5. The headline was performance. I rewrote the bitstring implementation in Hologram's client-side Elixir runtime from scratch and got a 50 times rendering speedup. That's what makes smooth pointer move events like this possible in this SVG drawing demo. Version 0.5 also brought expanded DOM event support, sessions and cookies, live reload, and much faster incremental compilation. I also replaced WebSockets with HTTP, because when your logic runs on the client, you're only hitting the server occasionally, not on every interaction like live view. And servers and events handle real-time server push cleanly. So no WebSockets, no firewall issues, no cookie workarounds. See that bouncing ball? Version 0.6 introduced action scheduling. That animation is running at 60 frames per second, pure Elixir. But the big thing in this release was full-form support with state-synchronized inputs. Remember this one from the start? Version 0.6 made it possible. Now, there is a significant slowdown between September and December. After 2 years full-time on Hologram, that wasn't sustainable long-term. I started taking contract jobs alongside it, working 60-hour weeks. Curiosum and the Erlang Ecosystem Foundation stepped in. Curiosum became the main sponsor, and the EEF awarded a stipend. Combined with GitHub sponsors, that got me back full-time on Hologram. And speaking of Curiosum, they've got a stand here. That's my HQ for the conference, so come say hi. And you can play the Space Invaders written in Hologram from the beginning. Version 0.7 was special. This one was a community effort. I asked the community to help port JavaScript, to help to port to JavaScript Erlang functions that Elixir standard library depends on. And 49 contributors pushed over 700 commits and ported 150 functions. And it was more or less across 19 Erlang modules. So we went from a third of functions we need in the browser to almost all of them. Next up, JavaScript interop. In Hologram, you write pure Elixir, but when you want to reach into the JavaScript ecosystem, like a charting library, a browser API, or an NPM package, you can, and it's clean. JS import from chart.js, and you're ready to go. Data types convert automatically between Elixir and JavaScript. JS promises become Elixir tasks. Web components work in templates. You can dispatch JS events from Elixir, and JavaScript can dispatch Hologram actions back. So that was the release list, but there's another story. Release by release, Hologram's client-side Elixir runtime has matured a lot. It's paired with a compiler that traces every page's call graph, shipping only the code that each page uses. So No bytecode, no full beam files. And because the runtime is in JavaScript and WASM, we can piggyback on what the browser provides. So that's together 100 kilobytes compressed. And a WASM runtime shipping beam files would have been multiple megabytes. Tooling is catching up too. We recently shipped VS Code extension, and Formatter and DevTools are coming soon. So, local first. I've been designing a local first data layer for Hologram, but that term means different things to different people. Here's mine. Local first means your UI is never blocked by the network. Reads are local, writes apply instantly, app works offline, sync catches up when it's getting back online. The term was coined in a 2019 essay by Martin Kleppmann and friends at Ink and Switch. 7 ideals, you are there, worth reading. Some still use it for peer-to-peer, no server, data only on your device. In 2026, most people mean the definition I gave you. Okay, so the definition is in place, but why does this matter? 3 end-user wins. 1, the UI feels instant. No round trips, no spinners. 2, users can work offline when the network drops. 3, autosync. Updates from other devices and teammates appear in real time. Offline edits catch up the second you reconnect. Now, some of you are thinking, we already do this, right? We broadcast updates with PubSub. You can, but broadcasting is fire and forget. Offline clients miss events, and on reconnect don't know what they missed. You maintain state on the client yourself, you reconcile yourself, you write the plumbing yourself. A sync engine is built for this problem. It guarantees data end to end. Your client has the data, the server has the data, they stay in sync. The engine keeps them in sync, not you. PubSub gives you events, a sync engine gives you state, without you writing a single line of plumbing. Once you have that, a whole category of front-end bugs just evaporates. Loading states, cache invalidation, rollback, choreography, all gone. So, why isn't everyone doing local first? Because it's hard and nobody's quite agreed on how. Let me show you why. Any local first system has to answer a handful of design questions. Here's the design space. 1, where does truth live? On the server, or is every client equal peer-to-peer? 2, how are conflicts resolved? 2 users added the same thing at the same time. What wins? 3, what happens offline? Can the client write? Does it queue writes? Or is offline read-only? 4, how much data does the client have? All of it, a subset tied to the current user? How is the subset defined? 5, how do queries stay fresh? We run them every time, update them incrementally as data changes? 6, how does the schema evolve? Add a column, change a type, rename a field. What breaks? Every product picks differently across all 6. I'll dig into a few. Take the first question. Where does truth live? 2 camps. The server authoritative camp says the server is the source of truth. Clients can run optimistically, apply the write locally, the UI updates instantly, but the write isn't committed until the server accepts it. If it rejects the write, the client rolls back. And replica 0 and InstantDB live here. The peer-to-peer camp says every client is equal, no central authority. Conflicts are resolved by data structures called CRDTs, data types that are designed to merge cleanly no matter how they are edited. Auto-merge, YJS, and JS live here. Now, as you can see, CRDTs are genuinely cool idea, so why isn't the whole space just CRDTs? Because CRDTs guarantee convergence. They don't guarantee invariance. A schema says things like, email is unique, foreign keys resolve, balance is greater than 0. These are invariants. Properties your data has to satisfy at all times. CRDTs can guarantee those. Two offline clients each create an account with the same email. The merge produces a duplicate, because both rights were valid at the time. The invariant is broken. And that's the cap theorem biting. During a network partition, you pick consistency or availability. You can't have both. CRDTs pick availability, traditional databases pick consistency. Martin Kleppmann, one of the authors of the Local First essay, put it cleanly, CRDTs are a tool, not a complete architecture. So what actually ships in production? Hybrids, server authoritative for business logic and invariance, CRDT flavor for collaborative text, presence, rich text, things where automatic merge earns its keep. So those are the design questions. Now, what the industry actually settled, and what's too messy? What does the space has broadly agreed on? 3 things. 1, for server authoritative products, Postgres is the default anchor on the server side. Elixir, for example, syncs Postgres shapes directly to the clients. 2, client storage is moving toward SQLite in the browser. IndexedDB still ships in plenty of places. 3, reactive queries are kept fresh incrementally. This is an application of IVM, incremental view maintenance. Full recomputation is no longer acceptable today. Now, what's not agreed on? Not agreed on. This is where the real work lives. Write paths. Every engine does this differently. Most hand the hard parts back to the developer. Offline writes, mostly unsolved. Most products claim support and hand-wave the reconciliation. Zero rejects them outright. Elixir intentionally scopes them out, focusing on reads. Permissions, universally weak. One product, InstantDB, has a declarative rules language. Everyone else hands off back to you as HTTP handlers or JWT claims. Schema evolution, also universally weak. Everyone hand-waves what happens when data shape changes. And let me zoom on this one. So schema evolution isn't one problem. It's actually 3 stacked. 1, the write signature changes. Yesterday, complete task takes a task ID. Tomorrow, it takes a task ID and a user ID. All clients send the old shape. Queued writes have the old shape. New servers expect the new shape. What happens? 2, the data behind the write changes. The write used to flip a Boolean, now it also writes to a new events table. Name is stable, behavior evolved. Both shapes coexist in flight. 3. The local read model changes. Even if writes don't change, the client's local tables might. For example, add a column, split a table, change a type, the client has a replica in old shape. The server has moved on. So 3 problems, most engines solve 0 of them well. Now, here's the interesting part. A compiled language doesn't have to hand-wave this. And then there's the biggest gap. Not technical this time. Every serious sync engine in 2026 is a JavaScript first. Everyone. The Elixir ecosystem is unserved. Ruby is unserved. Python is unserved. Local first is becoming the new data layer. And the JavaScript monoculture owns it. But that's not a problem. That's Hologram's opening. So Hologram has structural advantages the JavaScript ecosystem can't replicate. 3 of them, actually. One language for the whole app, UI, mutations, permissions, schema, all Elixir. Remember the first question every local first system has to answer? Where does truth live? Hologram's approach will be mostly server authoritative. Clients write optimistically, server arbitrates. CRDT support for specific parts, collaborative text, present, it's on the table. For that, the same write logic has to run on both sides. In most stacks, that's 2 implementations. Or careful isomorphism that splits the code between server and the client. Hologram compiles Elixir to run on both sides, so one source, server, and client, that's part done. 2, OTP. Every sync engine on Earth reinvents supervision trees. Fan out, message routing, back pressure, reconnection. We've had all of that for decades, built-in. Gen server, PubSub, registry. This is sync infrastructure, right? And shipping in production basically for 3 decades. 3, metaprogramming plus call graph analysis. Elixir has macros, real-time code generation, not runtime decorators. A macro evaluates arbitrary logic at compile time and emits code. Hologram has call graph analysis. It already uses it to ship only the code each page needs. Combine them, and you get a compile time toolkit for sync no JavaScript stack has. Take automatic partial sync. Imagine your UI shows a list of tasks. The compiler can trace it. I mean, your schema and query are both macros, compile time code, not runtime strings or config files. When the page uses the query, the compiler can trace it through the schema all the way to the exact slice of data that the page needs. Nothing to declare, nothing to annotate, sync would follow the code, not config. And because the compiler knows every client's query at build time, IVM could also run on the client too. Per client deltas, not full recomputation. That's one idea. There are others too. Schema, mutations, permissions, the design space is wide open. I've got other ideas, and if you've got other ideas, I'd love to hear them. Now, compare that to everyone else. Most sync engines give you primitives. Partial sync, write it yourself. Permissions, write it yourself. Query language, here's a YAML file. Hologram's philosophy is batteries included. Partial sync, automatic. Permissions in Elixir. Queries in Elixir, schema enforced at compile time. IVM on the server too, not just on the client. And it's possible because we control the full pipeline. So, to sum up, the local first data layer is part of the bigger picture of the Hologram plan. Cross-platform from one repo, local first, declarative data store. Also, awesome compile time guarantees, so that's where the Hologram is going. And before I wrap, a few thanks to my partner Emilka, years of my dinner table Hologram monologues, and she's still here. My friend Tomasz for helping design Holograms, front-end internals, and to my sponsors for keeping the lights on. Curiosum, main sponsor, stands down the hall, come say hi, I'll be there, check out their open source too. And the Erlang Ecosystem Foundation. If you're not a member yet, sign up. And my GitHub sponsors. If you'd like to help, join them. Thank you. There you go.
Thank you very much, Bart. That was a fantastic talk. If you have any questions, then come find him at the Curiosum stand or elsewhere here in the conference. Or if you're following online, ask the question in the conference app and he will get to it.
And come play the Space Invaders.
Come play the Space Invaders. Thank you. Let's give another big round of applause for Bart.